Yeah. Okay, so, you know, that's the closest thing to an Indiana Jones theme that I could do. The About Me page is kind of not used anymore, but there's something that I did mention to Pierre, which I have here. It's that I'm an author and team member at CodeDrops as well, and this is a screenshot of my website. You can check it out for CSS and SVG articles. I write about these topics a lot. So SVGs, it's an XML-based vector image format for two-dimensional graphics with support for interactivity and animations. Basically, SVGs are tags that render images and shapes, like we mentioned, and they're becoming very popular today. The reasons why SVG are getting very popular are, there are many more, but some of them are, they are scalable and resolution independent. So no matter how many new iPhone 6s and 6+++ we're gonna get, SVGs are gonna look awesome on all resolutions, including print design. They have very good browser support. They're supported in all modern browsers, and by modern, I'm including IE 9+. They're not supported in IE 8, but we do have techniques for providing fallback for non-supporting browsers, or even browsers that do support SVGs, but for some reason may not be able to render the SVG referencing. They're accessible to screen readers if you make them accessible. They're accessible in a sense that they have a very accessible DOM API, and they're accessible to us developers via the DevTools, because we can inspect and manipulate SVG nodes just like we can inspect HTML elements in the DevTools, apply styles, remove them, just like HTML. They have smaller file sizes than their JPEG and PNG counterparts. SVGs are XML documents, so they are basically text, and they can be gzipped, and therefore have smaller file sizes, which is always great for performance. They have built-in graphics effects. You have clipping, masking, blending modes, filters, lighting effects, basically Photoshop in the browser. And they are interactive and stylable with CSS, JavaScript, and even there are native animation elements inside SVG, which are known as SMIL, or actually they are part of SMIL that have been important to SVG. And there are a lot more reasons. So we have every reason to start learning and working with SVG today. However, when I first started learning SVG a few months ago, I bumped into a lot of walls. I had certain expectations from SVG, and the most basic expectation was that I expected SVG to behave similar to HTML in many aspects. But what I didn't know back then is that SVG and HTML are like two completely different universes. They have certain things in common, but there are some fundamental differences between the two that may get you to bump into walls or want to bump your head into a wall because you can't figure out what's going on. One of the simplest and yet most important differences between SVG and HTML is that in HTML you have what is known as a content flow. If you have an element that has a certain width and you have a lot of content in that element, if it doesn't fit, or if it's going to be wider than the element, it's just going to flow into another line. We have a concept of lines. The browser fills the first line. Once it's full, it's going to start filling the second one. But in SVG, there is no content flow. And SVG is basically a canvas, and you're positioning elements absolutely on that canvas. There is no flow. Like if you have a big headline and you want it to wrap in SVG, it's not going to do that. If it's wider than the SVG viewport, it's just going to get cut off. And if you want to get multiple lines in SVG, you're going to have to manually split the headline or paragraph of text or whatever into spans, and then position those spans on top of each other, specify the line height or the space between the lines manually. It's not really fun, but this is what SVG is. I was also overwhelmed by the many techniques that we have for embedding SVGs. We have 6 ways to embed an SVG on a web page. And I was like, some of them were completely new to me, like I had never heard about them. So it can be overwhelming if you don't know the differences, the pros and cons of each. So what I'm hoping through this talk is to give you a starting point that will help set your expectations from SVG a little straight, and hopefully save you some frustration along the way. So I'm going to be covering creating, exporting, and optimizing SVGs so that you have an SVG file that you're ready to work with, styling SVGs with CSS, animating them using CSS transitions and animations, embedding them, the different techniques, pros and cons of each, making them cross-browser responsive. It's not as easy as it may seem. There are certain fixes and hacks that we're going to need to apply to make them cross-browser responsive, and making them adaptive using CSS Media Queries. There's one feature about Media Queries in SVG that I'm sure you're going to love. And just a little bit more at the end. OK, so Creating, exporting, and optimizing SVGs. There are many SVG editors out there. The three most popular ones are Adobe Illustrator, which is not free, but I'm pretty sure all of you are familiar with it, and it's a favorite to many designers out there. Inkscape is a free alternative, and it's also fairly popular. And Sketch, it's not free, and it's also Mac OS X only. I'm pretty sure that 99% of you are on Mac, but if you're stuck on Windows like me, you're not going to be using that. Now, no matter which editor you use, none of them outputs perfectly clean and optimized code. SVGs exported from editors usually contain a lot of redundant information, like you have editor metadata, comments, non-optimal decimal values, like that you'd have 4, 5, 6 decimal values, empty groups, a lot of them, especially from Illustrator. So it contains a lot of redundant information that you can safely remove without affecting the rendering result of your SVG. So it's generally a good idea to use a standalone optimization tool to optimize your SVG for you. There are several optimization tools, but I'm gonna go over 2 of them only, and I'm gonna recommend one of them. The first one is Peter Collingridge's SVG editor. This is an online tool. It allows you to either upload an SVG file or input SVG code directly into the form, and then you get to see a live preview of your SVG. Next to that, on the left, you're gonna get a set of options. These options are actually the optimizations that you can apply to the SVG. You can specify how many decimal numbers that you want, like combining paths, etc. Many optimizations that can help slash your SVG file size to the half. However, there's one advantage to this tool that I really love. Being able to see the result of applying on optimization is a very big plus, because sometimes certain optimizations may end up breaking your SVG, like completely breaking it. For example, combining paths may work in one SVG, but it completely can also break your SVG too. 1 decimal value should normally be enough, but sometimes it's just not enough. You're going to have to go with 3 or 4. It can also break your SVG. So being able to see the result of applying the optimizations is a big plus. I have an example here. The first one on the top it's a very simple path that you can create in Illustrator. So I exported it. You can see the size before optimizing it, and at the bottom, this is the result after I've optimized it using Peter's tool. Much smaller, much more readable, and, well, a lot better. Now, this is the tool that I recommend because, again, I repeat, some optimizations may break your SVG. So being able to see them, you get to choose what you want to apply and what you don't want to. If you don't want to use an online tool, you can use the SVGO, which stands for SVG Optimizer tool. This is a Node.js-based tool, and it comes with a nice and simple drag-and-drop GUI, as shown in the slide. However, this has one disadvantage, which is that you never know if the optimizations you're applying are going to break your SVG. It broke my SVG once. It broke a lot of people's SVGs. It's not the tool's fault. I've learned that you can choose the optimizations you want, but you're going to have to choose them before you actually apply them. So you may choose some optimizations, apply them, end up breaking your SVG and having to redo it one more time. So my personal favorite, the one that I use and that I recommend, is the Peter's online tool. OK, so after you've optimized your SVG, it's ready to work with. You can start styling it with CSS. Now, the dividing line between HTML and CSS is clear. HTML cares for the content and structure, and CSS cares for the looks. However, in SVG, that line is blurred, to say the least. SVG 1.1 did not require any CSS, and so it was necessary to present the styles in what is known as SVG Presentation Attributes. Presentation attributes are kind of a shorthand way for setting a CSS property on an SVG node. You can think of them as special style properties that are set as attributes. They even contribute to the style cascade, but I'm going to get to that at the end of the section. The code in blue, we have the width, height, fill, stroke, stroke width. These are all presentation attributes. Now, in SVG, there is like a really long list of presentation attributes. Only a subset of these presentation attributes can be set in CSS as CSS properties. The following table shows the list of attributes that we can set in CSS. Some of these attributes are already implemented in CSS, are part of CSS, and can be used on HTML elements, and others are SVG only. Now, Because only a subset of presentation attributes can be set in CSS, we have, for example, width, the width attribute, the height. We have X, Y, CX, CY. These specify the position of an SVG element. We still cannot set these in CSS, but we will be able to set them in SVG too. More attributes are going to be added, so I have a link to the full list. If you want, you can keep an eye on this. Actually, I think that in Chrome Canary, you can already set the width and height and position of SVG elements. Okay, so because presentation attributes can be set as CSS properties, you can include the styles and properties in many different ways. The first one is setting them inline inside a style attribute. Inline styles, just like HTML, but on SVG. You can see that the fill, stroke, and stroke width that were previously presentation attributes are now CSS properties. You can set them inline. You can set them in a style tag inside the SVG. In this case, you would have to select the SVG element that you're styling and then apply the styles to it. SVG elements can be selected just like HTML element, using ID selectors, class selectors, whatever. You can also include the styles in a style tag outside the SVG if you're embedding the SVG inline in an HTML document. Notice that in this case, usually when you're using SVG, there's an attribute called XML namespace that you need to specify. But if you're embedding the SVG in an HTML5 document, notice the doc type, you don't need to explicitly set the XML namespace. And last but not least, if you want to completely separate your SVG code from the styles, you can reference an external style sheet using the XML style sheet element. Okay? So, style cascades. Presentation attributes are special CSS properties, so they will contribute to the cascade. But how do you know if you have an element, like a circle in this case, and you apply a full color using inline styles, presentation attribute, an external document style, and I have a group here. The group element in SVG is used to group elements together in SVG. So if you apply a style to a group element, all of the elements inside the group are going to inherit that style. Okay, so in this example here, I have a circle. The circle has presentation attribute set, inline styles, inherited color, and styles applied inside document styles. Presentation attributes count as lower-level author style sheets, and they are overridden by all style declarations, whether they are inline. You would think that presentation attributes are like stronger and would override inline styles and external styles, but they don't. They count as lower-level style sheets, and they only override the user agent style sheets, which are the default style sheets applied by the user agent, which is the browser. They can also override the inherited styles, but that's just it. If you have a presentation attribute, it's going to override user agent style sheets and inherited styles, and it's going to be overridden by any other style declaration outside of that. In the diagram, styles lower in the diagram override those above them. So you can see the order of styles in the cascade. Next up, animating SVGs. So we can style SVGs using CSS, so it only makes sense that we will be able to apply transitions and animations to them using CSS as well. Animations can be as simple as a very simple hover effect. For example, in this case, this is an example from the iconic icon set. In this example, we have a lamp. The lamp lines are gray in color, and in order to create the effect of the lamp being lit, once the lamp is hovered, you can see, I took a screenshot of the DevTools here to see that you apply the styles just like with HTML. So once the icon is hovered, the stroke color changes to yellow, the stroke width increases, and there is a light gradient background color that you can also add. Very simple interaction. You can do that using inside SVG. But most animations are usually going to contain some kind of transformation. Rotation, translation, scaling, whatever. In most cases, SVGs respond to the transform and transform origins just like HTML elements do. However, there is one inevitable difference that you should be aware of. The transform origin in SVG and HTML is very different. In HTML, we have the concept of Well, we have a box model. The box model is made up of the margin box, the border box, the padding box, and the content box of the element. And the transform origin, if you're going to transform an element in HTML without changing the transform origin, it's going to be 50% by 50%, which is the center of the element itself, calculated relative to its content box, relative to its box model. But in SVG, SVG elements don't have a box model. They don't know what a padding is or what a content box is, none of this. So the default transform origin of an SVG element is 0, 0, but it's not the top left corner of the element itself, it's the top left corner of the SVG canvas. So if, for example, we have a div in HTML and a rectangle in SVG. The small red circles represent the default transform origin in HTML on the left and SVG on the right. If you're rotating both the div and the rectangle by 45 degrees, the HTML element is going to be rotated around its own center, but the SVG element is going to be rotated around the top left corner of the SVG, which in most cases you're not going to want. So in most cases, actually, having the transform origin at the top left corner of the SVG canvas is not going to be a problem if you're not rotating anything. Scaling, skewing, everything works as expected. But with rotation, obviously, it does not. So you will probably want to change the transform origin to make it the center of the element or any other point that you want. To set a transform origin in SVG, you can set it either using percentage values or using absolute values. If you use percentage values, the percentage value is going to be set relative to the element's bounding box, which includes the stroke used to draw its border. Like if you have an element, whatever it is, and you apply a stroke to it, this is kind of similar to a border in HTML. If you set the transform origin in percentages, it's going to be set to the element's bounding box. But if you use absolute values like pixels or ems or whatever, they are going to be calculated relative to the entire SVG canvas. So if we're going to go back to the previous example where we have rectangle and the div, and we set the transform origin to 50% by 50%, this is enough, this should be enough, to set the transform origin on the SVG to be the same as on HTML. And so when you start rotating the SVG elements, you're going to get the same results you expect from HTML. However, setting the transform origin in percentages is simple. You'll probably want to do that. But there is a bug in Firefox, and it has been around for a really long time, and I really hope it gets fixed soon. Setting transform origin in percentages does not work. In Firefox, you're going to have to use absolute values instead. There is a bug. It has been around for a really long time, and I really hope it gets fixed because we need that. So for now, you're going to have to either use just absolute values or use both percentages and absolute values. Percentages would work in Chrome and Safari, for example, and the absolute values would be for Firefox. So this is a very simple and basic example, a pinwheel rotating around a center. I've set the transform origin in percentages for Chrome or Safari or whatever, and using absolute values 193 pixels by 164 for Firefox. Then using the CSS animation property and keyframes, you can define an animation and apply it to the SVG just like you would with HTML. Okay, so what about 3D transforms? They work. You can apply 3D transformations to SVG. But there's always a but. Bugs, again, but this time it's Chrome. The perspective currently doesn't work in Chrome. If you're transforming an element in 3-dimensional space in Chrome, it's going to look flat and 2-dimensional. Also, there's another thing. 3D transforms and SVG elements are currently not hardware accelerated in Chrome. They have the same performance profile as SVG transform attributes. They are hardware accelerated in Firefox to some extent, but if you have like an HTML element and an SVG element, and you're applying 3D transformations to both of them in Chrome, you may notice a difference in performance between the HTML and SVG, and that is simply because of the fact that it's not hardware accelerated on SVG in Chrome yet. So CSS transitions and animations can be used to animate any of the properties shared with CSS, right? But there are certain SVG attributes, the subset that cannot be set. You know, we said that there's a subset that we can set, animate, transition in CSS. But there are certain attributes that we still cannot animate in CSS. Now, one of the most powerful features of SVG, and probably the most impressive SVG animations, are those that are going to include some kind of path animation. Like, for example, this one. This is an example I got from CodeDrops. It's using SVG. You start with a kind of like a cone-like shape, and it's animating. The shape is animating into a rectangle. This is actually an SVG path, and it starts with a shape and animates into another shape. However, to animate an SVG path from one shape to another, you're going to have to animate the D attribute, which is the data attribute. And the data attribute cannot be animated in CSS yet. So if you're going to animate SVG paths, I recommend that you use the Snap SVG library. Snap SVG is described to be the jQuery of SVG. Just like jQuery makes using HTML or working with HTML easier, Snap SVG makes working with SVG a lot easier. Another thing that we can do in SVG that we currently still cannot do with CSS is animate an element along a path. This is a very simple, basic example. I have a circle, and I'm just moving it along a path. I'm doing this using the Animate Motion SVG element. This is a native SVG element which allows you to animate the motion of an element along a path. You specify the path that you want, and then you animate the element along that path. By the way, I'm including links to all of the code pens that I have, so if you want, you can play with the code live later. So animating an element along a path is currently not possible using CSS. However, a few weeks ago, this time there's a but it's a positive but. A few weeks ago, Dirk Schulze, he's on the CSS and SVG working groups, and he proposed the idea of having CSS properties that allow us to animate elements along a path. This is one of the features that we would like to have, and it's one of the features that is missing from CSS animations. So he proposed it, and less than 2 weeks ago, it made it into a W3C editor's draft. Yay. So yeah, so this is really great news, and I think that implementations should start very soon, and he said that maybe next year we will be able to do this. We will have animation along a path in most modern browsers. Yay. Okay, so you've exported your SVGs, you've applied styles, you've animated them, now you want to embed them on the page. You have 6 ways to do that. Which one would you choose? And why exactly are we talking about embedding techniques in a talk that's about styling and animating with CSS? Well, the reason for that is that the techniques or the way that you embed your SVG on a web page is going to determine whether or not the CSS animations and interactions, like hover interactions, are actually going to work or not. You have 6 ways to embed an SVG. The first one is using an image tag. Just like you would embed a JPEG or PNG image, you can embed an SVG using an image tag. If you've applied CSS animations to your SVG, they are only going to work if they are specified inside the SVG. You've seen before that you can reference an external style sheet. If that style sheet contains animations, they're not going to work. They're only going to work if you specify them inside the SVG in a style tag. Okay, CSS interactions like hover interactions, like, for example, suppose you have a logo and you want to apply some kind of animation, like if you hover over the logo, some simple animation happens or change of color or whatever. It's not going to work if you're going to embed it as an image tag. I've seen a lot of questions on Stack Overflow, people having problem with this, like, I've styled the SVG, the animation works, I've tested it, but once I've embedded it, it didn't work anymore. So this is why. Interactions are not going to work. The same thing applies to a CSS that, to an SVG that is used as a background image in CSS. Animations are only going to work if they are specified inside the SVG, and interactions are not going to work. CSS interactions are not going to work. JavaScript and SML are like a completely different story. You can also embed an SVG using an object tag. Now, the object tag has very many advantages. The first one is that it comes with a default fallback mechanism. Between the opening and closing tags, you can specify any fallback that you want, so that if the browser does not support SVG, or if the SVG cannot be rendered for any reason, it's just going to render the fallback between the tags. It can be text, it can be a PNG version or JPEG version of your SVG, anything you want. And the object is also probably your best option if you're going to include scripting and interactivity using JavaScript. CSS animations and interactions are only going to work if they are specified inside the SVG. The embed tag, I personally don't have any use case for the embed tag. It's never been part of any HTML specification, probably. I'm not really sure about the history of this tag, but it has something to do with, long time ago, Adobe Flash plugin, whatever. So this tag was introduced, you can use it to embed an SVG. Animations and interactions work only if they are specified inside the SVG. An iframe is very similar to an object tag. Because SVGs are documents and they can be rendered on their own right, you can use an iframe to embed them. The only difference that I can think of between the iframe and object is that scripting your SVG or controlling it using JavaScript is going to be a little bit harder from the main page if you're embedding it in an iframe. It also comes with the fallback mechanism between the opening and closing tags. And just like the object and embed, animations and interactions are only going to work if they are specified inside the SVG. The last way we can embed the SVG is inline in an HTML document. Now, this comes with certain advantages and disadvantages. The first disadvantage is that there is no default fallback mechanism like the previous object and iframe. And if you have a very big SVG, it can end up increasing the file size of your page and cluttering it if it's really big. So I personally don't like this unless you're just using a small piece of code. But it has one big advantage, that CSS animations and interactions are going to work even if they are specified in an external style sheet. OK, so that pretty much covers everything about embedding techniques and how they affect CSS animations. After you've embedded your SVG, you're going to want to make it fluid, OK? I don't think anyone still works with fixed layouts these days, or at least they shouldn't. So if you're going to make your SVG fluid, there are certain steps that you have to do. And sometimes you're going to have to apply certain fixes and hacks to make it cross-browser responsive. Most of these fixes are for Internet Explorer, duh. Yeah. So the first thing to do, when you export an SVG from an SVG editor, it will usually almost always have a width and height set to it. So if you keep the width and the height, it's going to have a fixed dimension. It's not going to be responsive. So the first thing to do is to remove the width and height attributes. Second step, add the viewbox attribute if it's not already present. In most cases, almost always, it's going to be there when you export it from an SVG editor. But I've gotten a lot of questions like, I've written an article about making SVGs cross-browser responsive lately, and a lot of people followed the article, and they still came to me on Twitter and were like, OK, we applied the fixes and the hacks, but it still wasn't responsive. And when I checked the code, it was just the viewbox missing. You need to have a viewbox. Without a viewbox, it's not going to be responsive, even if you apply fixes and hacks. Set preserve aspect ratio to X-mid, Y-mid, mid. Now, you may or may not need to do this. The value X-mid, Y-mid, mid is the default value for the preserve aspect ratio attribute. If you don't have a preserve aspect ratio set, you don't have to set it, because it's just going to default to this value. But if you do have it set, and if you're not sure how to use this attribute, because there's a lot to say about this, so I'm not going to talk about this at all. So if it's not set at all, you don't have to set it. But if it is set to another value, it's better to set it to this one. Basically, what this value does is it's going to scale your SVG up as much as possible while preserving the aspect ratio, so it's not going to get distorted, and keeping it inside the viewport of the SVG so that it doesn't get cut off. Okay? Note that the preserve aspect ratio has no effect if the viewbox is not set. Why? Because the preserve aspect ratio is basically used to scale and position the viewbox. So if you don't have a viewbox, preserve aspect ratio is going to be useless. Then you're going to embed the SVG and apply fixes and hacks where needed. Once you've removed the width and height from the SVG, most browsers are smart enough to determine the width and the height. Like, for example, in Chrome and Firefox, they are smart enough to know that the width is going to be 100%, and it's just going to scale. It's just going to work. It's going to be fluid. But there's one case that they don't do that. I'm going to go over it. And in most cases, Internet Explorer is dumb to you're going to see, OK? So if you're embedding an SVG as a CSS background image, you don't have to apply any fixes and hacks. It's going to be responsive. You can position it and scale it and control it using background properties in CSS. No fixes or hacks are needed. If you're going to embed it using an image tag, OK, so what's going to happen? The fix is you're going to have to use image width 100%. This is going to make it cross-browser responsive. But why? This is actually required for Internet Explorer. See, in CSS, if you check the CSS specification, there is a place you have to really dig in to see it. It says that non-replaced elements are going to default to a size of 300 pixels by 100 pixels, 150 pixels, if the browser is not really sure what the dimensions are. It's just going to default to 300 by 150. Now, Internet Explorer is, I'm not going to use the word smart. It is, it just sets the width to 100%, but it keeps the height at 150 pixels. I mean, why? Yeah, so of course, if the width is going to scale and it's going to extend and shrink, and the height is fixed at 150 pixels, you're going to get a lot of white space on both sides. So in order to fix that, you're going to have to explicitly tell Internet Explorer, hey, the width is 100%, hey, wake up, okay? So scale the SVG as necessary. The same thing for Internet Explorer. If you're using the object tag, you have to explicitly tell IE that the width is 100%, and the same for the embed tag as well, also required for Internet Explorer. If you're using an iframe, you're going to need the padding hack, and this is required for all browsers. What's the padding hack? I'm pretty sure that some of you may have heard about it, some of you may have not, and others have probably worked with it, but don't know that it's called the padding hack, because I got a lot of people who told me that. They were like, oh, OK, that's the hack she's talking about. So when you're using an iframe, this is the problem. All browsers, including Firefox and Chrome, are going to set the width and the height to 300 pixels by 150 pixels. So you're going to have to apply a padding hack to make it responsive. This GIF, shows before the padding hack without it on the top and with it at the bottom. So what is the padding hack and how exactly does it work? I'm going to first list the steps and then show a visual explanation. To make the SVG responsive, you're going to first have to wrap it in a container. Then you have to collapse the container's height and then apply a top or bottom padding such that the resulting height to width ratio equals the SVG's height to width ratio. So why? How? The thing is that in CSS, when you apply a padding, even if it's a padding at the top or the bottom, if you're using percentage values, the value is going to be calculated relative to the width of the element, not the height. So if you set padding top to 50%, it's going to be 50% or half the width of the element, not the height. So imagine that if you've collapsed the element to a height 0, it doesn't have any height anymore. So, and then you're going to apply a padding, and the padding is going to extend the element again so that it has a height, but the height is going to be relative to the width, because that's what the padding does. Once you've applied the padding, the element inside it, which is the iframe, is going to be pushed down. So in order to push it back up, you're going to have to position it absolutely. You create a positioning context inside the container, position it absolutely, and give it height and the width. Okay, so I have a visual explanation here. I was unable to upload it, so here it is. So this is just basically the steps that I mentioned before visually. First, I've wrapped the SVG inside a container. You're most likely going to use a div because, well, it's just a container. It doesn't have any semantic value, semantic meaning. And then you can choose any width that you want for a container. In this case, I've chosen it to be 50%. Depending on where you're putting it, just choose any width. Then collapse the height. Notice how the borders, the pink borders represent the borders of the container. So it's been collapsed. After that, the ratio, the height and over the width ratio of the SVG is, in this case, for this logo, it's 0.95. So you get the height to width ratio of the SVG, and then you multiply it by the width that you specified for the container. In this case, the padding top is going to be equal 48%. So notice how the height to width ratio of the container is similar to the height to width ratio of the SVG. And notice how the iframe has been pushed down after you've applied the padding. So in order to push it back up, pull it back up, we're going to use absolute positioning. Position relative on the container, and then you set position absolute on the iframe, top and left, position it at the top and left, it's up, and then you're just going to have to give it a width and height which are equal to the container. I was a little slow here. Okay, so now that after you resize, it's fully responsive. So here, thank you. So this is the padding hack. 1, 2, 3, 4, 5, 6, the steps that we mentioned before. I've just added the slide. Instead of using specific values, I've used formulas like the width can be any width value here on the top. And the padding top is going to be equal SVG height over SVG width times the width value. And last but not least, if you're going to embed the SVG inline, you're also going to need to use the padding hack, but only for Internet Explorer. Okay, so you just grab the SVG tag inside a container and follow the same steps that we did before. And to resize, it's going to be fully responsive in all browsers. Now, in addition to making them fluid, you can customize the way SVGs look on different screen sizes using CSS Media Queries. This is very similar to HTML. So if you've worked with HTML and SVG and CSS Media Queries before, you know how this is going to work. We have, in this case, I have an adaptive logo. If you have a logo or any image or anything that you want to look different on screens and different screen sizes, like if you have a very small screen estate and you don't want it to take too much of that space, you can choose. Because every element in SVG is selectable, you can just select. For example, in this case, I have a curved background, and I have a stroke color, I have a fill color. So in order to make it look different on different screen sizes, I'm using CSS Media Queries inside the SVG tag. Okay, so the first thing that I did was remove the curved background and change the fill color, as you can see here, the image in the middle. And then when the screen becomes even smaller, I've removed more elements and more elements as it gets smaller. This is the example once you've resized it. Of course, you need to remember to make it fluid first, and then you can customize it on different screen sizes as you want. But there's one thing here that's really awesome about SVG. The sizes specified in the media queries refer to the size of the SVG viewport, not the size of the page viewport. So this is basically element queries inside SVG. Okay, the SVG viewport can be either the width and the height of the SVG itself. If you're embedding it inline, you don't have any container. The viewport of the SVG is going to be the width and the height of the SVG. But for example, if you're embedding the SVG using an image tag, the width and the height of the image tag are actually going to be the viewport inside which the SVG is going to render. So this is just a note that I wanted to mention. And depending on the size of the SVG itself, it's going to change. This is basically element queries inside SVG. OK, last but not least, don't forget to make your SVGs accessible. This is very important, and I can't emphasize this enough. There is an article written by Leonie Watson on the SitePoint.com. This is a must-read. It contains almost all of the information that you need to make your SVGs responsive. So please do read it. There are many things that you can do, like we have a title tag, description tag, a lot of things that you can do to make them accessible. This is important, so do read it. And last but not least, optimize and degrade gracefully. These slides by Todd Parker of the Filament Group are excellent. I've recommended them before, I still recommend them. They contain a lot of tips from working with different SVG editors, tips for creating SVGs, exporting them, optimizing them, automating workflow, providing fallback, a lot of tips. If you're going to work with SVG, those slides are goldmine. I totally recommend that you read them. Of course, I have links to the previous article and to this one. And that's pretty much all I have to say. Thank you.